In this lecture, we are going to understand I2C based EEPROM. So, till now you understood the concepts of I2C protocol, and you know how the data is transmitted, how the address is transmitted, and what is the format of the data packet. Okay, so on our microcontroller, we have an I2C bus which resides. So to make a communication or to demonstrate how this bus works, we need something on the slave side also. Hence we are considering this I2C based EEPROM on our slave side, and we will make transmission, that is we will write the data and read the data from that particular EEPROM. Okay, but before that you need to understand how that EEPROM works. Okay, so we are going to learn, or we are going to understand how this EEPROM works, and we are going to understand its specifications also. Alright, so I will open the data sheet of this EEPROM now. So this is the EEPROM that we are going to use, that is 24C16. So this means we are using an EEPROM of 16 kilobits. Okay, 16 kilobits, that means 2 bytes. So let me explain you the memory organization of this EEPROM. So basically, this is a 16 kilobits of EEPROM, right? That means 2 kilobytes, right? So if this is your memory, right? So it starts from 0 cross 000 to 7FF. 7FF means 2047, and this is 0. So this is the range of your memory of the EEPROM, and it contains pages of 16 byte each. Okay, so 16 byte each pages means 2048 divided by 16, which is equal to 128. So there are total 128 pages, right? So this is page number 0, page number 1, right? So similarly it goes up to page number 127, that is 0 to 127, right? And each page it contains of 16 bytes. Right. So when we write data into the EEPROM, so we need to consider the page as well as the byte address. Okay. So these two things we need to consider every time we write into the EEPROM. Okay. So this was all about the memory organization. So this was the memory organization, and if you go down below, then they have explained the device operation as well. So in the device operation, they are explaining how the start condition works, how the stop condition works, how can you input the data, how can you receive the acknowledgement bit, right? They have basically defined everything. So now let me show you the data format in which we have to transmit or read the data from this EEPROM. So if you scroll down below, then yes, for writing a byte into the EEPROM, a single byte, so this is the format for that. So for that, first of all you transmit the start bit, then you transmit the device selection address, that is the device address. Okay, and following the device address you will transmit the read or write bit, right? And after you transmit this 8 bits, the device address will be of 7 bits, and the 8th bit will be your read or write bit. Okay, so after this 8 bits are successfully transmitted, then you will receive an acknowledgement bit, and after you receive the acknowledgement bit you have to transmit your byte address, right? And after the byte address is successfully transmitted, you will receive your acknowledgement. Okay, and after that you will transmit your data, and again you will receive the acknowledgement and then the stop bit. So this is your whole structure of writing a byte into the EEPROM. Now what we need to understand is the device select address and the byte address basically. Okay, so these are quite important while programming. So the device select address is fixed basically. So it is hard coded into this EEPROM that the address of this device is this. So as you can see, this is the whole table. These are the 8 bits for device selection. So the first 4 bits are fixed, that is 1010, right? That is A. Okay, and the next 3 bits, okay, after A, the next 3 bits are the address bits, right? And the final bit, it is for read or write. So basically if you put 0, then basically it will write into this EPROM, or if you set this bit as 1, then it will read from this EPROM. Okay, so these are the this is the formatting of this device select address, right? And after this comes your address at which you want to store your data. So this is this. So as you can see, it contains 8 bits, that is A0 to A7. And in this EPROM, addressing of 11 bits is possible. That is, we do the addressing of 11 bits. Okay, but in the address byte there are only 8 bits. And where are the rest of the 3 bits? So the rest of the 3 bits, they are present in this device select. That is, as you can see, A0 to A7 are present over here, and A8 to A10 are present in this device select, right? So your whole address will be divided into these two variables, you can say, or these 2 bytes. So in while programming, you have to take care of this. So this was all you need to understand about the I2C based EPROM.